All right, well, hello everyone and welcome to the session, 0 to 60 with PowerShell on AWS. I'm Steve Roberts, a technical evangelist at AWS, and joining me is Andrew Pearce, a senior dev engineer. In the session, we thought we'd give you an overview of PowerShell at AWS. Now, most people think, when we talk PowerShell at AWS, they think of the AWS tools for PowerShell, the modules we released a few years ago. But there's so much more to it than that. We're going to give a brief overview of those tools in case you haven't seen them. And we're going to use them throughout the session. But then we're going to talk about PowerShell with AWS Systems Manager, another place where PowerShell gets exposed at AWS. Desired state configuration and AWS Systems Manager. And of course, serverless PowerShell. Hopefully some of you managed to, or maybe all of you, managed to get to Andrew's session this morning on serverless PowerShell. But we're going to do a brief coverage of it here as well, hopefully to whet your appetite if you've not seen it. OK, too fast. So, AWS tools for PowerShell. This is what most people think of, I think, when we talk about PowerShell at AWS. We released the first module for this back in 2012, and we announced gallery support on May 14th, 2015. So we've been keeping up with trends in the PowerShell community, supporting the gallery, etc. It's still also pre-installed on all Amazon EC2 Windows images. So you can take a script that you develop on your local workstation, deploy it to an EC2 instance, and just start running. It makes it super easy. Now, back in V1, back in 2012, we had about 550 commandlets at launch, supporting about 20 services or so. In the release we pushed out last week, we've now grown to 5,510 commandlets across 160 plus services. That's the vast majority of the programming surface of AWS. Now, at this point, I feel the urge to apologize. This is all in one module, right? Back when I was the dev lead for this set of tools back in 2012, I really did not anticipate the growth in AWS services and APIs. So I apologize. Yes, it takes a while to load the module. We're looking at, or the dev team now is looking at, can we remodularize this? Can we break it down to
service modules? Looking at Mike too.
Sorry?
Got someone trying to stop the feedback.
Oh, okay. Can we remodularize, etc., etc.? Obviously, that dev work is kind of in the investigation. Do I need to shout?
That's better.
Oh, okay. The work's on. I don't have an ETA for when it'll be done yet, but we're heading in that direction. We know this is unsustainable. We're trying to fix it. So again, I apologize. I did not anticipate this. Okay.
And to quick point out there, that's 2012. Right? That's a long time ago now that we had PowerShell support for AWS. It was one of the first SDKs. .NET, I think, was one of the first SDKs.
.NET was the first SDK.
So it's been Windows kind of heavy for a long time.
So back when PowerShell Core or PowerShell 6 was released, we were there on day of launch. I had the great honor of recording some videos with Jeff Snova in the Channel Line Studios, which another fond memory. And we released it to the gallery, again, supporting the gallery about a week later on. Both modules advance in lockstep. So as new services are released, as new service APIs are released, we very quickly roll out, or we're trying very quickly to roll out PowerShell support for those. As of last week, the AWS PowerShell .NET Core module has now reached 100% compatibility with the Windows PowerShell module. So the Windows PowerShell module, or AWS PowerShell as it's known on the gallery, that can be used with PowerShell version 2 through 5.1, I think it is, on Windows. PowerShell Core 1 supports, obviously, PowerShell 6, but we've now adopted PowerShell Standard. What this means is you can now run this module on PowerShell version 3 through 5.1 on Windows, or PowerShell 6 on Windows, Mac, or Linux. So now you have really portable scripts. In fact, on my own dev system, I've now switched over to the NetCore module, and I run that everywhere, because I don't have PowerShell 2 support.
I think half my team has as well.
Yeah. So yeah, the massing commandlets for SAML Federation were added last week by the dev team and released in that April update. This is a funny little chart that we dug out.
I have a question, Steve.
Oh.
Yes.
Yes.
The .NET Core version will run on 3 plus on Windows PowerShell and PowerShell Core full stop. Yeah. The AWS, yes. Linux, Mac, PowerShell Lambda, containers, everywhere. So yeah, that question in here, is our module cross-platform? And yes, the .NET Core version is. The AWS PowerShell named one is not.
And hopefully at some point we'll consolidate to a single set of modules, when we module, etc. But again, that work is in the future. It's being looked at now. Andrew put together a nice little script that analyzed the gallery releases over time for the PowerShell modules. You can see that it just keeps going up and to the right. right, which we think is great, but there's some significant bumps on here. You can see the, excuse me, nearly fell off the stage. You can see where our annual AWS reInvent conference comes along. You can see that sudden bump in support, right? As new services are announced at reInvent, we try to get the PowerShell support out as fast as possible. Sometimes it's a lot of services we need to onboard. We do use CodeGen a lot, but we still need to onboard and test it, etc. But you can see the hockey stick effect.
What does the y-axis represent?
The y-axis is the number of commandlets in the modules.
Yeah.
And about, let me see, where did we cross 4,000? Around about there. Yeah, that was when we broke publishing to the PowerShell gallery. It turns out that we listed all the commandlets that are in the modules inside the manifest as a good practice. It turns out there's a hidden limit of 4,000, or there was a hidden limit of 4,000 on that list, even though you can have as many commandlets as you like in the module. The PowerShell gallery team were awesome. They helped us work around this, etc. We're still, to this day, not listing the commandlets in the manifest, so you do need to explicitly import the modules. Again, when we remodularize, that will all get fixed in the dust.
Yeah, there's auto-loading for aliases, but not for the actual exported commandlets in the module.
So yeah. Okay, so other significant releases, well, based on community feedback back in 2017, we did a big rename of some of the commandlets and parameter names. We take backwards compatibility very seriously, so this was a slow thing for us to do, but we managed to release a whole load of renames, etc., without breaking anybody. If anybody who's in this room gave us feedback on what we should change, etc., thank you very much. It's really appreciated. And as you can see here that 2018 was a massive year for PowerShell and AWS. A whole load of stuff came out. PowerShell Core on our Amazon Linux instances, PowerShell Core in the code build images, etc., and of course Lambda support. So yeah, 2018, a huge year.
And one that we actually apparently missed on that slide was DSC support. So I think there's another slide on DSC, but quickly now, we did launch native DSC support within AWS Systems Manager last year in October. Yeah. We'll demo that today.
So I've talked a lot about the modules, what's in them. So basically, that's a lot of commandlets, right? 5,510. Each commandlet pretty much maps one-to-one to an AWS service API. Some commandlets wrap multiple APIs. The actual modules themselves sit on top of our AWS SDK for .NET. So they take advantage of all the authentication, etc., authorization that's in there, all the on-the-wire marshalling. You don't need to worry about any of that. You're not calling a REST API. You're calling a logical API. Underneath the covers, it does all the work for you. Some of them wrap higher level APIs. So for example, if I want to transfer an object or a file to S3, I'm going to use write S3 object. That commandlet sits on top of the transfer manager utility that's inside our SDK. That transfer manager utility is smart enough to look at the file and say, hey, it's up to 5 meg in size. I'm just going to do a single put request. Or it's a bigger file. I'm going to break it into chunks automatically and send those up. You as a PowerShell dev, you just write S3 object, huge file, bucket, go. You don't care, all right? Makes it really, really simple to code with. But the primary point here is, if you can code something in an SDK, you can write it in PowerShell because of that mapping one-to-one. If you can find the SDK documentation, you can figure out how to use an API, et cetera, et cetera.
And that is a really key point because there's some services like DynamoDB which you don't have commandlets for yet. I know
we don't have the data plane commandlets.
Yes, we don't have commandlets to interact with data inside a DynamoDB table. You can create the table. You just can't communicate with the things inside of the table from a PowerShell commandlet. But because we ship the entire SDK with the module, you can fall back to the .NET client and communicate with any AWS services using the .NET clients from PowerShell. So you've got the entire coverage, even if there's not a commandlet for it.
Question?
Why don't you have commandlets for the data stuff in Dynamo? Because DynamoDB is really painful to use.
Yes. Yep. So there is a GitHub repo we'll link, go file issues. But on the .NET Developer Center, we do have code samples now for PowerShell on that, and we do have full user stories for get, put, query, scan, with filtering, with expressions, all user samples in PowerShell of how to do it from PowerShell. So that's at least there now that you can find and use.
Yeah, and additionally, when we added the control plane APIs for Dynamo, back when DynamoDB was launched, we were looking at the data plane APIs, and in the SDK, there are actually 3 different models for communicating with DynamoDB. Yeah. The raw API level, a document, and an object model API. We were not really sure how people were going to use DynamoDB from code. So rather than write a bunch of commandlets that we need support for evermore, because we take that backwards compatibility really, really seriously, it was like, okay, let's sit back and wait and let the community tell us what they want. To be honest, for a while, we didn't hear anything. right? And people were more happy to build the infrastructure than they were to code against it. But now that we have PowerShell Lambda, we're starting to see more and more requests for, I want to use DynamoDB data from PowerShell. So again, we're kind of
so the examples are currently with the document database, the document API, which is very JSON based. So it makes it a lot simpler from PowerShell where you can just create a JSON and put that into your table. Whereas the other ones, it's a JSON with not a clean naming that's nice for humans to interact with. Yeah. So the document DB that's very much JSON based is a much simpler way, and that's what all the samples we have demonstrates.
But again, if you go to the PowerShell repo.
Yes, file issues.
The tools, by the way, are not open sourced at the moment. Hopefully one day they will be. There's some stuff we're going to do in the generator first before we do that. But post an issue on that repo so the dev team can see it and they can see that at that interest level. Yeah.
Any issues at all with any of the commandlets, file issues. Issues are what make work happen.
Okay. So that's the basic intro to the tools that we have that most people think of in PowerShell at AWS, but we have so much more. It's PowerShell and Systems Manager. This is Andrew's favorite. So what is Systems Manager? Well, it's an operational service. It's like, we like to think of it as like a single pane of glass across your cloud resources, right? At least your compute resources. So if I've got all these instances running in the cloud and I want to do patch management on them, baseline management, I want to execute command documents against an entire fleet of EC2 instances, no matter how large, Systems Manager is the thing to go to for that. But it can also do on-prem. So now I can take my on-prem instances, my cloud resources, take a command document with a PowerShell script in it and say, hey, run this against that entire fleet. Okay? All you need is a Systems Manager client running on the on-prem instances.
And that's an outbound call. There are no inbound ports. It's a purely outbound 443 connection from the client. And that makes all the communications work back and forth. Yeah. There's no firewall ports.
So we'll actually go through some Systems Manager demos in a little while. We want to get through all the slides first, then we'll go to demo land. So that's more fun. So again, where can I use PowerShell with Systems Manager? So run command, we mentioned running a command document, which is basically just a script with some metadata that tells you what the parameters are, et cetera, and run that. State Manager, drift
schedule
detection.
Schedule run command, basically.
Yeah. Session Manager, which we're going to show in a little bit, so I can remote into a running instance without needing any open ports. Again, the outbound connectivity, and compliance and inventory support. On to Andrew's favorite, desired state configuration.
Yeah, so we've had a few people asking about this on AWS this week, and yes, we officially do support DSC in AWS. This does not use the LCM. We are doing essentially the same as Puppet Chef, the other companies are doing by using Invoke DSC resource. But we've built some integrations with other AWS products into this. So credential management, you're not putting creds into a MOF file. You're not having to encrypt the MOF file in that respect. There's other token lookups that we have in the document, so we'll demonstrate that today. But this is officially supported today. It integrates with compliance and other things in AWS, and it is actually actively being developed as well. So we do have DSC support.
Mm-hmm. And of course, serverless PowerShell.
Yes, hopefully you're in my 90-minute talk this morning.
Hopefully.
If you weren't, we'll hopefully get some demos for this. These are kind of the last ones because of this morning. But yeah, I mean, we have production-ready PowerShell support in Lambda today. It launched September last year. It's all open source, so you can go and look at the code yourselves. There's a module on the gallery, the AWS Lambda PS Core, which provides wrapping tooling to hide all the .NET stuff that's happening behind the scenes from you. So you can just write PowerShell code, deploy from PowerShell, and get a very PowerShell experience when using Lambda.
Yeah, it's important to realize that there is no PowerShell Lambda runtime. It just sits on top of our .NET Core 2.1 Lambda runtime, the same way our .NET Lambdas run. Okay, but using that Lambda PS Core module, it gives you the same support that you have in, say, our Visual Studio tooling, for example, where you can give new project blueprints to get started really quickly, as well as all the publishing commands that you need that package everything up and send it off to Lambda. It makes it really, really simple and really quick to get started. Okay, with that,
demos.
We're going to move on to some demos because that's more fun, right? Yay!
Yay! Hopefully they work.
Fingers crossed.
All right, so I'm going to do this from a server running in EC2. Especially when I get to Lambda, I don't want to publish 10 megabytes from the Summit Wi-Fi, so I'm just going to do it from an instance. So let's start with parameter store. Why not? Bit of an order here. I want to introduce a few of these before I get to DSC, because the DSC demo uses some of these capabilities. So
parameter store is a part of Systems Manager, and it's effectively a key value store. Okay, so you can store runtime configuration or any kind of configuration data in there. It supports, as Andrew's going to show you, strings, string lists, which is a comma separated list of strings, or secure strings. And you can query that data back at runtime or when you need it, again, from PowerShell or from your running scripts, for example, say in Lambda, if you deploy to PowerShell Lambda.
Yeah, and so it also supports pathing. So the demos I'm going to deploy here, I'm going to deploy with the slash to deploy path-based parameters, and I can query them back based on the path that I'm actually supplying as well. So it's not a whole lot of code, right? Right, SSM parameter is the command that we're going to use.
I have a question, Andrew. So
yes?
How did you know the command that was write SSM parameter?
And that's a fun one, because what is SSM? There's not actually an AWS product called SSM anymore.
No.
So the PowerShell tooling has a commandlet called get AWS commandlet. Commandlet name.
Yeah, what we did back in V1 when we created these tools was, obviously we had 20 plus services, one module. Some services have the same API names, right? Describe instances is an API name at AWS that is used by at least 3 services. So we needed a way to namespace the commandlets. So what we decided to do was to add a prefix to all of the nouns in the module. So EC2, S3 are obvious ones, etc. Right? You can see here there's at least, yeah, there's still 3. So the question is though, how do you know that the commandlet name in this case is SSM? How do you know what the prefix is for a given service? Well, there's a way you can find that. There's a commandlet called get AWS PowerShell version, which will list all of the service prefixes for the supported services, or, yeah, let's do that one, the list. So this is a good way of seeing what services are supported by PowerShell, by the PowerShell tools. You can see there's the prefix in the center. But if I don't remember that commandlet, let's use get AWS commandlet name, I can give a logical set of names to the service parameter. So let's try, I don't know, Compute Cloud or Systems Manager. This is the central discovery commandlet for the AWS tools. Now, there's a reason we're not using get command here. Get command didn't give us that introspect into what the actual API was, right? It just gives you the command names. Yes, you could do some slice and dicing, but this was a way of getting a deeper insight into what commandlets map to what APIs. So you can see here, here's all the SSM commandlets. There's the API that they map to in the service. The other thing we can do is we can take an API operation name and transfer it back to the commandlet name.
Yeah, so how does that describe instances?
That's how that one works, right? So if you find the API documentation, now you can get back to the PowerShell commandlet. And as we'll see later on, you can also translate AWS CLI. That's our cross-platform, or our original cross-platform command line tool before PowerShell 6 came along. You can transfer an AWS CLI command back to the PowerShell commandlet. So you'll find lots of examples of the CLI commands online, not so much for PowerShell because the naming is a little bit harder for the service teams to figure out automatically. But you can take that and then transfer back to the commandlet, and then off you go. Okay?
Yeah. And Systems Manager is a kind of special one. When it launched, it was actually called Simple Systems Manager, hence SSM. And then it got renamed at reInvent a few years back to AWS, or EC2 Systems Manager. And then it got renamed to AWS Systems Manager. But because backwards compatibility is so important for us, the commandlets are still based on SSM naming conventions. So this is kind of a special case to get renamed 3 times.
Yes, it's grown.
All right, so yeah, so that's why it's right SSM parameter, and that's how we found it. So the name is the name of my parameter, and as I said, it supports paths. The value, clearly the value of my parameter. The description, what type it is, a string, a secure string, or a string list. Now the overwrite flag is required to overwrite the parameter. By default, it will not overwrite the parameter. So this shouldn't exist. So you better run that with the splat included in the line. And you'll see that I get a 1 back. Now this is the version of the parameter that is returned from the API. So parameters in parameter store are versioned items. So when you create a new one, the old one still exists.
And you can query it.
And
so in that key name there, you see the /myService/ if you put the colon number at the end, you can get back to an original version of the commandlet, of the parameter version.
Yep.
Right, that value. I don't think we document that anywhere, but it's a little tip.
So I'm just going to write 4 up here just so we have some to query. So these are the exact same calls I just made, just with different values and different parameters. But you can see here I'm choosing secure string for one of these. So my value in this case is clearly plain text. But when I go to query this back, you don't see anything. And I'll query that back shortly, because you can also do rich objects, right? We have JSON support. JSON's a string. So take any object you want, convert it to a JSON, save it to a parameter, query it back, convert it out of your JSON, and you've got rich object back. So when you think string, string can also mean rich object. So obviously that will work as well. So retrieving them back. Get SSM parameters by path will give me all the parameters in that path that I've deployed, and if F8 works.
So basically, in other words, all the parameters have that same prefix path. Yeah.
And you can see here, one of these was a secure string. Just by querying it, I don't get the actual value back by default. So unless you explicitly ask the API to decrypt that value, you won't decrypt that value. So if I come down, apparently I'm doing that later on, but I'll do it here. If we do the same thing, but say with decryption, true, you can see now that my value came back as my super secret value. But Steve, I'm in PowerShell. Why am I saying with decryption true?
The reason you're saying with decryption true is that for some services, not present means different to true or false when you make the call, right? So because we code gen these, it's safest for us to say, let's assume it's a Boolean rather than a switch parameter. Now, it's not always the case. It's certainly the case in the auto-generated commandlets. We do maintain a few. Out of that 5,510 commandlets, there's about 20 that are maintained by hand, right? And those will use switch parameters because we know what we can do there. But the auto-generated ones generally will just emit a Boolean. So yeah, it's not quite PowerShell standard, but you know, we can't auto-detect not present versus true or false means something different to different services. So we take the safe approach.
Right, so yes, so the question was, is secure string our own type of encryption for secure string? When you write a parameter value, by default, your AWS account has it's called a KMS key, so Key Management Service is our encryption service. Your account has one by default. So if you don't specify a key, we'll use your account's default and encrypt the data using that key. You can specify your own KMS key, which can be auto-generated for you through the KMS service, or you can provide your own encryption keys to that service, and it'll encrypt it with that key instead of the default one for your account.
Or create your own keys from PowerShell.
Yes.
KMS is a supported service in the commandlet. So.
Yeah. And so this is, you know, as you'd expect, I can retrieve multiple parameters back, multiple parameters with decryption back. So you can see I am piping this, right? I'm getting a parameters by path and piping that through. So a lot of work I think has been done in the code gen to give pipeline support to these commandlets, because it's an API call, and as we all kind of know, the REST method commandlets don't always pipe nicely out of them. So I'm sure as you probably did a lot of work to make sure that worked properly.
We got it wrong in version 1, I'm sorry, but we fixed it shortly after.
And I can remove them just as easily by piping to remove.
So we're showing you the by path approach here because this makes for an interesting use case, right? If I'm deploying PowerShell applications and I want runtime configuration, I can put everything under a common key prefix with different leaf values. And then when that application runs, my PowerShell app runs, I can get back all my configuration settings in one fell swoop, right? Form up a JSON table or a hash table and just go from there, as opposed to querying for individual parameters. So there's a question of
how do you support should process on some of these state
So the question is, how do we support should process? The way that code gen works is that it looks for certain verbs in the operation, so deleting things or creating things. And so by default, it generates all commandlets as a medium, I think, medium confirm impact. But if it sees something that's going to delete something, then it makes it automatically makes it a high priority and then adds the should process information into it.
All right. I've done a bit of work here while Steve was talking there. I've just flipped over to a Secrets Manager demo. So Secrets Manager is a service that's very similar to Parameter Store when you look at what the services do, but it's explicitly built for secrets management as opposed to configuration and general data management like Parameter Store. So Secrets Manager has automatic integration to services like relational database services for MySQL, where you can tell the service when you create your database, just put my credential over here, and rotate it for me all the time. You can also do your own rotations using custom Lambda functions and have the service trigger your Lambda to rotate your credential inside Secrets Manager. So it's explicitly built for secrets. There are different in the cost pricings for these, so go and check out the cost differences and make sure you're happy with the service you're going to use. But we wanted to demonstrate this because this, the DSC capability plugs into this as well for credential management. But there's not a whole lot different here that you'll see from the commandlets than there are with the SSM commandlets, so we'll probably run through this one pretty quick. But this is a really cool function that I like, get random secret. You can choose characters to exclude, characters to include, and it gives you a randomized string. So on PowerShell core, where you don't have the web namespace, this can be a really good way to generate random passwords or random strings to use within your code. So saving a new secret, I mean, I'm not splatting here, but I've got a name, a secret string, and a description. Right, I can save that up. This is, I've probably already got one deployed. But even if that fails, right, this is, the parameters are essentially the same as parameter store. Create a new one, remove it, update it. There's not really any difference there. But a cool thing here is you can obviously script over the top of our commandlets. So instead of taking a commandlet that takes a string value, I'm just going to load a couple of helper functions, and these will be on my GitHub repo, so don't worry that I'm not showing this. But we can write a function, I'm calling it save SEC credential, where instead of taking a string value, I'm going to take a Pearce credential object, and then inside my function, I can unwrap that into a JSON and save the JSON to the service. And alternatively, I can retrieve one back that gives me a Pearce credential. So the point here is kind of remember that these are just commandlets, so you can build your own commandlets on top of the AWS commandlets to help you do things you want to do. So here's a user, here's a crazy password that I'm going to just type. And I can save that into my account, and when I get it back using another wrapping function, it's a Pearce cred. So instead of having to use the AWS commandlets that give you strings and objects may not like, you can do things yourself to keep things in Pearce credential objects and nicer places for your PowerShell code using these APIs. So I just want to demonstrate that quickly to remind you that these are just commandlets that you can wrap around. Right. There's Secrets Manager. Again, all this code will be up online, but we didn't want to dive too deep on Secrets Manager because it's so similar to parameter store. Now, run command is a good one. So there's a bit of textual information at the top here. So as Steve said...
So you're going to make all these public on GitHub, yeah?
These all built on GitHub. So run command allows you to execute what is called a document against a fleet of servers on premises or in Amazon EC2. And those documents can do different things. For example, run shell script. Run a bash shell script against a Linux host. Run PowerShell script. Run a PowerShell script block against a Windows or a Linux host. Install missing Windows updates. Clearly, that's going to go on install missing Windows updates. There's a whole bunch of documents available for you, and you can create them yourselves. So
from PowerShell.
From PowerShell. So where run PowerShell script is execute this generic script block, you could generate a document like a function that is very hard typed in what it does and expose those to your support teams so they can run code on your Windows instances or Linux instances with very defined code of what they can do. And these API calls are logged. The output can be logged. All of this can be logged inside your AWS account, so it's all exposed and you can go and find it.
And remember, because the AWS PowerShell tools are pre-installed on at least on the Windows images currently, that means you can actually use our commandlets inside these scripts, right, to actually do real work on the instance itself.
So I'm going to retrieve a list of instance IDs, and we've changed a whole bunch of instances just before we walked in here, so I just wanted to make sure I got some. So I'm going to target some Windows instances here. I'm going to run the script block, PS version table, and I'm going to do this all from PowerShell, but I could use a console, but no one wants to do that. So I'm going to run the AWS run PowerShell script document. I'm handing in parameters of a string. This accepts an array of strings, which isn't the most PowerShell-like experience. And this is where sort of the wrap your own things around this comes into play. So you can wrap your own things around this call to give you a nice invoke PowerShell type experience. So I'm going to run that, and this is an asynchronous call. So I've got this object back, it's in pending state, and I've got this command ID, which is a unique identifier for that execution. It's finished already, so let's go and get the output. So if I run that's a get SSM invocation command, by default, you don't get the output back with it. It's more the metadata around the execution. So if you include this detail true parameter, you'll get the actual output back. Now this is limited to 2,500 bytes in this output, but you can tell a run command to output to S3, and then you get a pointer to the S3 object, and you can go and get it back from S3 if you've got a lot of data. So if I do this, right, we can see instances and the PowerShell version. So this is actually very quick execution, and I'm going to do that once more without as many breaks in the middle. So run that, in progress, success. All right. That was pretty snappy against 2 hosts, and it's the same really against any number of hosts you want to run it against. And this is all outbound connections from instances. There's no reaching in. So this is a pretty cool capability. I think I'm going to set Session Manager next.
I think we should.
Yeah, Session Manager is cool. All right, let's go over to my UI, my console. You can do this from the command line, but I'm going to do it from a browser because I think it's just as useful. So I'm in the right region. So I'm going to come over to the Systems Manager console.
So
Come
basically
down.
what we're doing here is we basically want to remote into this instance.
Yep.
One of these instances, right? But these instances do not have public IPs. They're sitting in a virtual private cloud. They have no connectivity from the outside internet in, right?
I'm going to prove that. I do not have any public IPs over here. These are privately addressed, NATed to the internet, can't reach in. There's no security group allowing me to come into them. So we're going to create essentially a remote interactive PowerShell session in my browser to these hosts with full tab completion support and everything. So if I come over to Session Manager and start a new session, pick one of my machines, and I now have a remote session, hopefully. There we go.
Ooh.
So here's Windows PowerShell. All right.
So you should be able to execute one of our commandlets from there.
I should.
Pick one.
Go Wi-Fi. I'm going to show that like I can hit tab here. This is going nice and slow. Tab. Tab. There you go. Tab works. So this is an interactive session. I can create through a web browser. I can use the AWS CLI to do this from a shell, like PowerShell as well. So you can manage your Windows or Linux boxes remotely with an interactive session with no inbound ports. And I think that's pretty cool. So I like that. So, I mean, is it going to be quick enough for me to run import module?
Now remember, it's got to load 5,500 commandlets. Bear with us.
All right, get S3 bucket. I should have access buckets.
There we go.
So we can do all the things in PowerShell in here, just like we could with remote PowerShell session. So what this is really good for is how many of you have DMZs with Bastion hosts or jump boxes? Right? They go away in this scenario. You don't need the jump boxes. You don't need Bastion hosts, because all those are doing is adding a security input into your environment. This, you don't have that. So this is a really good capability for that. It does work against an on-premises instance. You need to enable an advanced tier in Systems Manager, which comes with associated costs. So if you want it on premises, go and read the costs associated with that. Okay, we've got 10 minutes. So I'm going to go to DSC, because we've had a few questions at the conference about our DSC capability. Okay, I'm going to remove this bill. That'll be on GitHub. The main thing to note, actually, I'm going to show a bit of that. These two bits. So normal DSC, you use a PS credential object in your configuration, and the credential goes into the MOF file in plain text, if you specify plain text. or it's encrypted on your pull server or on your local machine using certificates, machine certificates, which means you need to manage machine certificates on all your nodes, or you don't encrypt your creds, and neither of those are a good idea. So what we've done is leveraging Secrets Manager and Parameter Store. You can specify the username in your Pearce credential as the unique identifier to that secret. The password is completely ignored, so blank, whatever you want. Ensure you publish your MOF with plain text, and I'll demonstrate this. And at execution time, your instance will make an API call, retrieve the secret, inject the secret as a Pearce credential to the resource, and run with the credentials namespace. And additionally with tokens, so we've called this token substitution, where if you have a string or a string list, a MOF today is hard-coded, right? You want to say, I want to use my system drive. You can't. You specify C:/. With this implementation, you can specify an environment variable, a parameter store item, an SSM tag, and at runtime, that token will be substituted with the actual value from your system. So if you deploy systems with different program files paths, you can reference your environment variable in a MOF, deploy your MOF all the places, and that will be resolved at runtime. So it's a little bit of a difference to everyone else's implementation of DSC, but it allows you to generate one MOF, deploy your MOF to production, test, gamma every environment, and change those configuration items at your local client if you want to. So let's demonstrate that. So, proof. Let's go over to, I closed it, my session. And I run some PowerShell code. Typical, well, I showed the before and the after to show that yes, we did apply something. All right, paste. You can do it. So I'm trying to do a local user and show that there is no local user configured because the local user requires a Pearce credential object in a MOF. And I was going to create a file on disk based on a tag replacement coming from Parameter Store. All right, they don't exist. Those files and paths don't exist. Okay. So I'm going to create a Pearce credential, and I'm going to demo user. Oh, probably should call this the same as the user I'm going to query for. Ah, there's a password. I'm going to save that credential into Secrets Manager using a JSON that has a username and a password. So this is where that wrapper function kind of would have been nice for me. And I have a unique identifier to that secret, and this is what I'm going to use in my code. I'm going to write an SSM parameter that I'm going to reference in my MOF. Now for my DSC configuration. So let's make this window a little bit bigger. So in my config, I'm going to hand in that unique identifier to my secret. I'm going to create a folder that is referencing the system drive environment variable. And the name of my file is going to be based off an environment tag on my instances. And the content will come from SSM, from my parameter store in SSM. Now for my user, you can see here that I'm creating a Pearce credential object with the password that's ignored and the path to my secrets user. And I'm using that in my user resource, and this is a Pearce credential object. So we'll run that, bring it into memory. And because I said we are using technically plain text in my MOF, but there's no credential in my MOF, so that doesn't matter, I do have to use configuration data to force DSC to create a plain text username and password in there.
Even though the password won't be used?
Yes. So let's generate my MOF file, and I'm going to go and show you what is inside the MOF. So here's my MOF. And if I scroll down to this one here, this is what a Pearce credential looks like in a MOF when you use plain text. Right, so no credential, super safe to stick anywhere you want, and this will be resolved at runtime from my instance. So I'm going to upload that MOF to an S3 bucket, and that's where my agent will install from. Now I'm going to use the Systems Manager State Manager capability here, which is kind of like scheduled run commands. So the DSC capability is exposed as a document, so it can be used through run command, like I demoed with run PowerShell script, or through State Manager, which re-executes that over time at scheduled intervals. So I'm going to remove any that exist, even though they shouldn't. Okay, let's create my association. So there's a lot of parameters on the document, and I'm going to walk through them. So the document name is AWS-apply DSC MOFs. If you want to find the documentation around this, Google that. Don't Google AWS DSC. You'll find a very, very old quick start, which won't help any of you. So that is the name to Google if you want to know more, or ping me on Twitter. I'll tell you what it is. When you write a run command or a state manager association, you can target instance IDs, so very defined finite things, or you can target a tag. So any machine that comes into my account with the name tag of Summit Demo will get this association almost instantly, and will run in my box. So you can deploy this once, stand up servers, tear servers down, and this will just start running on your boxes as soon as they come into the picture. MOFs to apply is an array of MOFs in a defined notation format, which is in the documentation. This is how we do dependencies. So the ordering of the MOFs is the order of the dependencies. We don't merge MOFs together, so there's no merge conflicts that you get with the LCM. These are processed as individual MOF files. Service path, just to find some logging paths in S3 for us. MOF operation mode, apply. We're going to apply a config. Compliance type, this integrates with Systems Manager Compliance and writes a compliance item to Systems Manager. And this is the path in the compliance, you'll see this, and I'll show you that. We have two types of reports. A report, which is a deep JSON object with all of the verbose output if you specify verbose logging, as JSON in an S3 bucket. So you can take action off that. You can trigger Lambda functions, you can process that, you can dive deep into that for troubleshooting. We also have a status object, which is a much higher level. How many resources are compliant? How many are not compliant? Am I in compliance? Am I not in compliance? So another really simple one that can be used in dashboarding. So it's a much smaller object for that. Do I want to install modules from the gallery? Yes or no. Do I want to install modules from my own S3 bucket? You have to specify none if you don't want it. It's just a quirk of how you have to define a document in Systems Manager. Reboot behavior. Reboot after all the things. Reboot after a single MOF has applied. Reboot never. There's some differences in reboot capabilities there that you don't have on the LCM. Use computer name or instance ID for logging. Do I want verbose logging? Do I want the debug logging? And the pre-boot script is good. If you apply this to systems in a load balancer, you can define a PowerShell script here to run before a reboot happens. So you can use this to go and pull your machine out of the load balancer, make sure you exit it cleanly before your system is rebooted. Now, if you're an Active Directory domain controller, do I have other domain controllers happy? Yes, I can reboot. DHCP cluster or failover cluster. Is my cluster healthy? Move all my things to other nodes. Now reboot. So this lets you do clean reboots from DSC. And these are some other other log outputs. So this is the literal PowerShell output that is run. Concurrencies, errors, scheduled to run at. That's all fairly straightforward. So let's create that association. So that's applied. That's going to be running against my boxes right now. I'm going to copy that and go to the console. So back in the Systems Manager console, on the left here, I'm going to do a State Manager. And I now have this association, which failed.
Oh.
Yes. Demo gods. Let's have a look why.
That makes me sad.
Failed. Here you go. Here's some output troubleshooting. In fact, did I record this demo? I can't remember.
You record, yes, you recorded.
If I did,
one for it,
let's
yes.
just quickly
But
throw that
we
on.
Might, well, we might have time.
No, I didn't. Okay.
You didn't? Oh, okay.
So instead of troubleshooting that, because we're at 44 minutes right now.
We
I will record this and throw it out on Twitter so you can all see this does actually work. But what it will do is it will actually come into this compliance pane on the left, and you'll actually see compliance items at every single resource level in your AWS account. And these can be tracked through other AWS products like Config, which can give you history over time of your compliance. So while the demo didn't work, it does work because we use it in production. So any questions?
Well, so back to the slides because we have a couple of links.
Yeah.
So that's 0 to 60, right? Going from the AWS tools for PowerShell all the way through to all the other places in like Systems Manager where you can use PowerShell, EC2 instances, etc., etc. GitHub links. These are for basically issues, or in the case of the PowerShell tools themselves, feature requests. Feel free, knock yourselves out on that one.
PowerShell Lambda is 100% open source
it's
on
100%.
the Lambda repository.
PowerShell links there for the gallery, which are fairly easy to find anyway, but also the developer blog. So we actually publish posts on there for PowerShell on AWS. I did one this week on Systems Manager's parameter store, being able to query what services are available in regions, etc., etc. With that, thanks all for coming. Hope you enjoyed the discussion.